Okay. So pada siapa yang tak score the first part, so this is the time for you to score the second part. So we will learn about von Neumann model. Actually von Neumann is a person name. He is the inventor of the electronic computer. So the computer, the evolution of the computer starting from the the non-electronic computer. Kalau you tengok note, if you see the notes, in 1943, there are two person, Eckert and Macaulay. They invented the first general electronic computer. This is a general one, just the simple computer, electronic gadget. How it works? It works through the setting of dials and switches. So dia tak ada konsep memory. Okay. The point or the mechanism that differentiate computer and other electronic gadgets or electronic objects is a memory. Itu the main difference. Perbezaan yang paling utama, yang paling nampak, the main difference between a gadget called as a computer and other peripherals macam TV or radio or any kinds of electronic things. Okay, the main difference is memory, the use of memory. Tu beza. You tak panggil, you will not call a TV as a computer. You will not call a watch as a computer. Your wristwatch, your hand watch, or maybe you will not call your electronic aircon, okay, air conditioner, anything, microwave, okay. You never call these peripherals as a computer. Ada ke yang panggil microwave oven tu sebagai komputer dekat sini? Tidak. Okay. So kenapa tidak? Tidak kerana microwave oven has no memory. RAM. Pernah dengar RAM tak? Have you ever heard about RAM? People talk about RAM. Terima kasih. There's a lot of type of RAM. We have DDRAM, SDRAM, SDRAM4, SDRAM5. A lot of RAM. The difference between all of these kind of RAMs is from the perspective of its endurance, capacity dia. The latest RAM can work more faster and can keep more data. Tu je beza dia. For the SDRAM4, DDRAM3, 3, 4, 2, everything lagi besar number, the bigger the end number is, it shows the faster RAM can works. Lagi besar nombor, lagi cepat RAM boleh bekerja. That's the difference between SDRAM 1, 2, 3 and everything lah. But that thing is not important. Just to let you know the basic info about RAM. The main point here is, like I said just now, the things that differentiate computer and other electronic things or peripheral such as air condition, microwave is a RAM. Okay. So back to our notes. So during the early stage of the computer invention, so there is no RAM. So computer dia masuk data, we key in the data and it will produce an output. That's it. So on 1944, is the beginning of EDVAC. EDVAC ni nama komputer, the computer names. So the computer EDVAC, dia mula ada, it started to use program stored in memory. So it means EDVAC is an electronic computer that has memory. So 1944, and then on 1945, there's one young man named John von Neumann. He has write a report on how the memory works in a computer. He just wrote a report, how the memory works in a computer. So the report name is first draft of a report on EDVAC. Okay, so this guy write a report, and in his report there is diagram that shows the component that the component that contribute to the definition of a computer. So that diagram contains memory, CPU, and control unit. Processor unit is a CPU, so don't be confused. If we talk about a processor unit, it means we refer to the CPU lah, okay, and then control unit as well. So let's see how does the diagram or the model looks like. Okay, so then sekejap. Okay, this is the diagram, how the models looks like. Simple je, it's very simple. So if we want to talk about the peripherals or gadget that can be defined as a computer, that gadget must have 5 components. Kalau tak ada salah satu ni, if the gadget doesn't have one of these component, it means it is not a computer. Setakat ni faham tak? Do you understand?
Faham.
Yang tak faham, ada yang tak faham ke? Kalau tak faham pun tak apa, boleh cakap tak faham. No, don't worry, boleh je. Tak ada okay. Saya harap tak adalah bila yang tak ada menjawab ni ya. Jangan simpan dalam hati benda yang tak faham, just let it out. I'm here to listen. Okay, so don't worry, saya tak marah pun kalau tak faham, saya boleh ulang balik Okay, so there is a 5 components that need to be have if we want to define an object or peripherals as a computer. So the main component, the most important component is agak-agak mana? From your opinion, which component that is there, the most important component? Which one?
Memory.
Of course, memory. Of course, memory. Thank you. Memang memory Sekejap, ada orang baru masuk. Dun Zianli. Okay, memory So memory is very important because this component differentiate computer from the others peripherals lah. Okay, so memory, and then then we have input like keyboard, mouse, and everything lah that can be used to key in the data into the computer. Like text, we use keyboard. Actually macam ni there are 5 types of data. Ada 5 jenis data. Okay, there are 5 types of data. Okay, the first one is text. Text ni tulisan. Okay, kemudian then we have sound, bunyi. Okay, and then we have image, gambar-gambar, foto, whatsoever. And then we have animation, and the last one is video. Actually, I do not know why they differentiate the video and animation. I don't know. So these 5 type of data is worldwide standard. So each of these data got its own input and output peripherals device. Okay, like text, I give you one by one. Kalau you nak conteng nota, if you have your own note, please jot down these things on your notes. In your notes, so you tulis apa yang saya nota-nota tambahan ni supaya senang awak nak faham bila awak buat revision. Okay, so up to you. You can write down manually using your pen, or maybe you can use the same slide and then you just put extra text box just to jot down notes on your own slide. So input, I give you the example of the input and output device based on the 5 data types. Okay, the first one is text. Text, worldwide standard. To key in text into the computer, we will use keyboard. Everybody knows keyboard, I'm sure. And then the output device for text, the data type is what do you think? It's a very simple one.
Monitor.
Monitor, of course. You can call it as a monitor. You can call it as a display or screen. Okay, it brings the same meanings. Okay, and then at the same time, you also can print out the text. The text. So if you print out the text, so the output device for the text is printer. So it depends on the usage of it. Either you want to see it on the screen, or either you want to print it out on the paper. Okay, so that is for the text data types. Text tulisan. Okay, and then the second one we have sound data types. So if sound data types, the input device or peripherals for sound is agak-agak apa?
Microphone.
Good, microphone. Saya sengaja tanya because some of my previous student will will give an example such as speaker. So speaker is not an input an input device. Speaker is an output device for the sound data type. Okay, settle. So we have two already data types, and then the third one is an image. So, to your opinion, what is the input device for image? You nak transfer something from everywhere to computer. What will you use? Scanner. Bluetooth tu Bluetooth tu how to transfer using Bluetooth? Dia macam mana how to define Bluetooth Bluetooth ni kan macam mana cakap receiver I don't know how to define Bluetooth because when we talk about input, it's more towards the device that we connected to that device. We ourselves connected to that device to transfer the data. Macam scanner kan? Scanner can be used to transfer the image from maybe from printed materials into computer. Kalau Bluetooth ni, macam mana nak cakap?
Kalau USB wire sir?
USB wire, Bluetooth itu lebih kepada macam jalan kaedah untuk transfer. Dia kaedah transfer, dia bukan alat untuk from where the input start.
Okay.
Kan dia macam mana cakap sebab saya pun tak pernah terfikir pasal Bluetooth bila tanya pasal input ni never mind, just forget about it. You just focus on the things that connected to you. Maksudnya kalau guna Bluetooth pun kena ada scanner kan, sebagai contoh. If you use wire pun, USB wire, you still need to have handphone misalnya to snap the photo kan. So the answer is more close to handphone instead of the wire itself. Macam tu lah lebih kurang Okay, boleh?
Boleh.
Okay. So the output device for image, you can print it out. Kalau print it out, you can use a printer, or if you want to see the picture on the screen, so the screen itself can be classified or can be set as an output device. Tak ada masalah So and then the animation and video. Okay, actually these two types of data has similar type of input device and output device. For video, for example, we have handphone, maybe handphone or camera, video, whatever the things that the device that we can use to capture the video lah. And then the output device also can be screen, also can be projector. Okay, if you want to project the video on the screen or on the wall, so the output device for that video data type is the projector. So it depends on the usage of the data. So tak semestinya satu there is no one example of output or input for one type of data type. So maybe it has many or more than one type of device for one type of data types. As easy as that. I think as a apa, I tak tahu you generasi apa, tak, I don't know that apa, the latest generation ni. I think you guys already familiar with all of these kind of computer devices. So that's it. So at this stage, so we already have memory. We already talk about memory, and we already talk about input and the output component that that contribute to the definition of computer lah. So the next component is a processing unit. Processing unit in the middle of the model tu, you can see the processing unit, or also known as a CPU, central processing unit, boleh juga. So this unit used to process the data. If you see inside the component, you can see the ALU and temp. Okay, temp stand for temporary storage. So a temp is used just to keep the data temporary when it going to be processed. Okay, so data will be kept temporary in temp. Alright, and ALU is an arithmetic logic unit. So A, we have learned about A, arithmetic. We already have L is for logic. So we already learned about logic, 5 types of gate. So ALU means arithmetic and logic unit. So CPU will process the data by using the arithmetic and logic concept, and the data that is processed during that time will be kept temporary in the temp. Macam tu After the process end, the process data, the final data will be sent back to the memory. You can see the anak panah, the arrow from input to memory, and from memory to CPU, and then from CPU going back to memory, and then to output. You can see the arrow tu not the dot arrow but the solid one. There are 2 types of arrow. You can see the solid one and the dot one. So I'm referring to the solid one. So you can see how the data flows from input to memory, and then to CPU, and then going back, return to memory, and lastly go to output. So clearly shows that the data that you key in from input, the first component that the data will reach or go through is memory, and all the data will be kept there. Okay, will be kept in the memory. When we want to use the data, and then the data will be taken out from the memory and sent to the CPU to be processed. Okay, in the middle of the model and then after process end, the process data will be sent back to memory, and then will be sent to output So okay, for the data that have not been processed yet, I will use the terms data. Saya akan gunakan istilah data to refer to the data that has not been processed yet. But the data that has been processed, I will call it as a information, maklumat. So that there are 2 different labels or terms for the same things. I repeat, for the data that has not been processed, we call it as data. But the data that has been processed, we will call it as an information. So the data and the information both will be kept in the memory. Itu the basic concept how the data flows from input to output. Okay, and then you can see in the memory it has MAR and MDR. Actually yang mana ada RR ni stand for register daftar. It likes it's mimic the record book. So it means that when if you want to take out the data from memory, we need to register first in MAR or MDR. MAR is for A for address, M is for memory, M for memory, A for address, R for register. MDR, M is for memory, D for data, and R is for register. So we need to register the address and the data if we want to take it out from the memory. Same goes to the information that we want to keep back keep into the memory, okay, before we keep into the memory, we need to register the MAR, the address and the data. Itu konsep dia. That is the concept. So why there are two things that need to be registered? Why? Okay, it is because in the memory is a big storage, it's a big storage. So if the storage is very humongous, very big, so we need to use a unique ID to identify each location. Macam rumah lah, in the resident, macam taman perumahan, in the house resident, each house has its own address, right? Betul tak?
Betul, sir.
Okay, terima kasih sebab respon. Okay, so kenapa kena ada address? Why we need address? Each a unique address for each of the houses in the resident. Kenapa kena ada?
Senang locate.
Senang apa?
Locate.
Senang locate. Yes, good. So we need the address to make us easy to locate the house. So same goes to the memory. Lagi besar memory, the bigger memory. If you have a bigger memory, we need to have a more address to locate the location in the memory. Remember, one location only can keep one bit. Maksudnya satu location, only one location only can keep one bit. So we need a lot, 1,000 billion of location to keep the data of the computer. So that is why the address is very important if you want to locate the data or if you want to keep the information into the memory. And then MDR is data. So when we have registered the address, so we can register the data lah before we take it out. Sama je macam kat rumah. Contohlah kalau you kat sekolah, if you in the school, so the teacher will take your attendance. So means that the teacher is recording your attendance. So itu tengah record lah tu. Register lah tu, daftar. So ada nama dan ada alamat. Ada address and ada data in the register. So and then the last component is control unit. At the bottom of the model, you can see there's a one component. The name is control unit, and you can see the arrow that come out from the control unit to other components. The arrow type is a dash one, not the solid arrow. So it means a control unit will control all the four components on top of it, on top of the model lah. Okay, so berbeza the solid arrow and the dash arrow is different. The solid arrow represent the data flow, data from input to output, while the dash arrow represent the control mechanism of all of these four components. Tu je. And then in control unit, you can see it has PC and IR. Okay, this one is quite technical. I don't want to tell you what is PC for and what is IR for. Let's go with the flow. Later in this note, we can see you can find out what is the meaning of PC and IR. So don't worry. Okay, until this page, any question?
Sir, ALU tadi tu apa?
Arithmetic logic unit.
Okay, thank you, sir.
Yang awak dah belajar, yang you all dah belajar dalam quiz sebelum ni, chapter 1, 2, 3 tu is arithmetic logic lah tu. Jadi apa yang you all belajar, what the things that you have learned in the first part of this course, what I mean the arithmetic and logic previously, actually I already tell you how the computer works. Itu je sebenarnya. Computer only works on arithmetic and logic. That's it. So computer tak pandai. Yang pandai lah manusia sebenarnya. Computer only can do two things, arithmetic and logic only. So A stand for arithmetic, L stand for logic. Okay. So any other question on this page? Siti Hajar, are you okay? Terus keluar si ada. Vignis. Any question?
So far no.
Nur Eliza?
No question, sir.
Bagus. Okay, good. Okay, yang bertanya pun bagus juga dua-dua bagus. Tak ada masalah There's no wrong and no right. Everyone is correct, right Okay. So we talk about memory first So the next slide we talk about memory. So how does the memory use the concept of address and data? So if you can see the diagram next to this note slide, you can see the red boxes, and then the number next to the box starting from 000 until 1111. Can you see that?
Yes, sir.
Okay. The number that next to the box, which is start from 0000 and 1111, okay, that is the address. This is the address of the location, while the boxes represent the location. So let's say the first box, the address for the first box is 0000. This is just for example to make you understand how the address and data being implemented in the memory. So this is the example how it works. So and then you can see in the red box, some of the red box has content. You can see like the box with address 0011, the content for this box is 00101101. Okay. Next, for the location with the address 1101, okay, the content of that location is 1010. 10101010. So you can see in this example, one location can keep how many bits? Berapa bit dalam satu lokasi kalau ikut example ni lah?
8.
7.
7 or 8?
8.
8 8. So, okay, how to calculate the size of memory? Okay, the size of memory ni mungkin you tak perasan, maybe you are not realize when you say about 1 gig RAM. If you say about 1 terabyte RAM, kan kata-kata macam ni familiar with you this kind of word is very familiar with you. 1 gigabyte, 2 gigabyte, 15 whatsoever, 32 gigabytes RAM memory. If you buy if you buy the handphone, you try to find out the bigger memory So how to calculate the size of the memory? That 32, that 6 gigabyte whatsoever lah. So the formula is 2 at the power of K times M. K is refer to the number of bit of the address. Let's say in this example, how many bit is used to represent the address?
4 bits.
4 bit kan? Okay, 4 bit yang sebelah kiri tu represent address. Okay, so K is 4. K is equal to 4. While the content of the memory, we label it, the variable is M. So in this example, how many bits of the content? 8. So the size of this memory is 2 and the power of 4 times M. Itu size dia. So berapa tu? 2 kuasa 4 kali 8. Cuba kira sikit guna calculator. We just want to see the how we can pronounce or say about this size of memory. 2 kuasa 4
428.
428. Isn't it? Betul ke?
Yes.
So the size of this memory is 428 bit. So very small. Can you imagine this kind or this type of example? This kind of example, we can call it as a 428 bit of memory. It's very small. you never see this size of memory. Normally we will say about 1 gig, 1 terabyte, 1 gigabyte. So can you imagine how long the address is and how big the content of each of the location is to get the 1 gig punya calculation, or maybe 1 terabyte or 6 terabyte. So of course, if you want to get that number 1 terabyte, 32 gigabyte whatsoever, so we need the RAM can locate or can keep more than 8 bits of data. Panjang, and the address itself maybe not be represented by 4 bit, maybe it can be represented by 8 bit of address. So all is possible. Okay, all is possible. So that is the size of the memory. So in this memory, there are 2 type of basic operation. There are 2 things that we can do on the memory. The first one is load. What does the load mean? Okay, load means read a value from a memory location. So it means that we take out the data from memory. Take out the data from memory. So when I say about take out the data from memory, okay, to your opinion, okay, where this data will be sent after we take it out from the memory?
CPU.
Yeah, CPU. We just refer to the previous model. You can see from memory, data will be taken out and send it to CPU. So that is what we call a load process, a loading process. Loading. And then the second operation is store. Store means write a value to a memory location. So what's your understanding about this? Write a value to a memory location.
CPU to memory.
CPU to what? Apa yang CPU to memory tu? Apa yang dibuat? What is happening from CPU to memory? The computer keep what?
Information ke sir?
Okay, betul. The computer keep the information from
CPU to memory.
From CPU to memory. Good. So the computer keep the information or process data. Okay, you can use process data or you can use information. Both have similar meanings. So from CPU to memory. As easy as that. Sekejap, ada yang menaip ke dalam ni? Sekejap, saya tak nampak. Keep data from memory. From memory to keep data from memory. Ding Ali, you need to understand from and to. If you use the word keep means from apa tadi? Please don't confuse yourself, Ding Ali. Don't confuse yourself. Keep means something that the computer send from CPU to memory. That is keeping or store. Okay. If you use sending means loading. Loading is from memory to CPU. Send the data from memory to CPU, or keep the data from CPU to the memory. You got that, Ding Ali?
Keep is taking the data from memory, or
keep means store. You keep the use of memory to keep the data.
Store. Understand.
Okay. The use of memory is to keep the data. The use of CPU is to process the data. So if you want to keep the data, so keep the data from CPU to memory, not from memory to CPU. That one is send. Okay. So keeping data means from memory to CPU. From CPU to memory, or storing process, or from the info, or you want to send the data. Okay, if you want to send the data, it means data will be sent from where?
Memory to CPU.
Memory to CPU. As easy as that. So don't be confused with the word. From and to is two different things. Keep and store or keep and send is two different things. So that is the meaning of load and store. Load means send, store means keep. That's it. Okay, any question?
Aku buat mission apa dapat offboard apa tak?
No, sir.
No
Thank
questions,
you.
sir. Clearly.
Okay, alright. So now, as we found out just now, there are two register or register lah, logbook in the memory. In the memory. So one is MAR. MAR stands for Memory Address Register. The second one is MDR, Memory Data Register. So as I said just now, if you want to keep or if you want to send the data, we need to register the address of the location of that data first in the register, and then you need to register the data itself also in the register. Okay. So this not, actually you are so lucky because you don't need to memorize the content of this note, because during the assessment or the exam you can open up this note. You can read the content of the notes. So your task is to just to make sure you understand the content of the note, not to memorize. So this is the advantage of online class and online assessment. So kalau saya jadi awak, if I being you, I will make sure I'll score all paper, because this is the time that can be used to, during the assessment you can open up the books, open up the notes. So for my class, we just need to understand the content of the slide. So if you have any question, just raise a hand or just ask me the question. So what are the steps in the loading process? Okay. So to load a location, let's say the location name is A lah. Okay. The address of the location is A. So what are the steps to take out the data from memory to CPU? So the first one is write the address into the MAR. So the control unit, if you see the model on the second slide just now, the control unit ni, this control unit will what? It will write the address of A into the MAR, and then the control unit will send a read signal to memory. So when this signal is sent to the memory, so the data of the location A will be registered in the MDR, and then read means send the data from MDR to CPU. So don't be confused. Read signal means the control unit read the data from memory. In the same time, the data will be registered in the MDR before it is sent to CPU. Okay. So I repeat, don't be confused. The second step here. Second step means send a read signal to memory. Okay, means that the data that the address is already written in the MAR. Okay, the data of the address that has been written in the MAR will be registered into MDR. This step is happening here. Okay, and then after the data is already in the MDR, and then the third step will be execute, where the data will be sent from MDR to ke mana?
CPU.
CPU pandai. Okay. When the data is read or sent from the MDR to CPU, okay, kan? Agak-agak awak, to your opinion, I'll show you the component.
50,000.
Okay, from MDR to CPU. To your opinion, okay, the data that will be sent from MDR will be arrive or will be keep in which component in the CPU? There are two components in the CPU, ALU and temp. So which one?
Temporary.
Temporary. Do you still remember what is the use of temporary? To keep what?
20,000 kan.
To keep the data that is sent from where? To keep the data that is sent from
10,000 kan.
Kenapa tak dapat jawab? Confused ke?
From memory ke sir?
10,000 kan.
Okey, sebab saya guna perkataan keep kan. Okey, dia punya flow macam ni. Okay, this is how the flow of the process. Okay, if you want to take out the data from memory, okay, the first step is control unit will apa tadi? Control unit will write the address into the MAR. So that's the first one. Okay, settle. And then the second one, the control unit will send a read signal to memory. So what is happening here is
Kau nak potong lain kan.
the data will be registered into MDR.
Nampak
Okay.
Max officer pun stress.
MDR so dia nak keluar dah ni, dah nak keluar. The data is just around the corner to be sent to the CPU. And then after the data is already registered into the MDR, after that the next step, the data will be read from MDR. Read means taken out or send. Read the data from MDR or send the data from MDR to, tadi you cakap to CPU kan, to CPU. So which component of the CPU will accept the data? Nak hantar dah ni. So which component? Dalam CPU ada dua komponen kan? So which component? Temporary. Okay, you kena tahu function. You need to know the function of all of these component, the bigger one and the smallest, the small one, the smaller one. So you need to know the function, apa fungsi MDR, apa fungsi MDR.
400,000 kan. Aku nak potong
There must be a function. Sebab kalau tak ada function, kenapa kena ada dalam ni kan? What is the need, what is the importance of this thing if there is no function kan? So you need to know the function of all of the boxes or symbol that this model have. Mesti ada function. Jangan buat jangan tak ambil kisah because all of this function has its own, all of this part component has its own function. So the function of temporary is again, what is it? To
keep the data from CPU to memory.
Okay, to keep the data from CPU to memory. Okay, if that is your sentence, awak tak salah Saya I just want to justify. If you said that the function of temporary is to keep the data that will be sent from temporary to memory. Okay, that one is a process data ataupun information. Itu adalah proses bagi information which is the temporary is used to keep the information or the process data telah diproses from processing unit or temporary to memory. Itu the storing process. So what about the loading process? If you want to define the temporary in the loading process, so how you can say about it?
It's 3 o'clock.
3 jam. Start pukul 2.
Macam mana you boleh define apa yang you boleh katakan about temporary? What you can say about temporary? If you want to load the data, just now is to store the data. Okay. So how about the loading process?
Pukul 5.
Nak cakap macam mana?
Pukul 4. Pukul 5.
Temporary will keep the data.
No.
Apa?
Makan.
Temporarily.
Okay, from now I'm talking about from where to where. Kita cakap daripada mana ke mana kan? From where to where? Okay, I repeat balik lah. So, okay, what is the basic operation that we can do on the memory? Baru je tengok tadi slide tadi. Apa proses yang kita boleh buat dalam memory ni, boleh buat apa?
Load dengan store.
Load dengan store. So, what is a loading process? Loading tu apa? Okay, cuba cerita balik pada saya.
Send data from memory to CPU.
Send data from memory to CPU. Okay, agak-agak kurang lah kan, to your opinion, data that is sent from memory to CPU tu untuk kita buat apa? Untuk komputer buat apa? What is the purpose to send the data from memory to CPU? Kenapa kena hantar data daripada memory ke CPU ni? Apa kita nak buat apa? Nak proses. Pandai. Okay. Which component that process the data?
Kelas bangsat. Dah 75,000 kan.
ALU, yes. Okay, good.
75,000 ajar aku.
That is the purpose of sending data, or loading pun boleh juga. Kita guna perkataan loading. We use the word loading. That is the purpose of loading the data from memory to CPU, which we want to process actually the data. Settle. Nama pun processing unit kan? So kita process lah. So which component that process the data? ALU lah. So what is the type of process? What is the what's the example of process that is implement or applied on the data? Apa jenis proses yang digunakan kat data-data ni? Ada dua je proses. Apa dia? ALU nama komponen dia. Okay.
Arithmetic and logic.
Bagus. So data yang dihantar, the data that was sent from memory to CPU is to be processed. So which component that process the data? So the component that process the data is ALU. So what is the type of process? What is the name of the processes? The name of the processes is arithmetic and logic. That's it. Okay, so the question now is, what is the use of temporary? The component labeled as TEMP, temporary. So what is the use of temporary? I already told you what is the definition, or what is the basic usage of temporary lah. So the data that just being taken out from the MDR, okay, will be sent to the CPU. So which component that will receive the data that was sent from the MDR just now? Which component?
Memory again.
No. I mean the data just taken, just being taken out from the memory through MDR, right? Okay, which component that will receive the unprocessed data? Temporary, of course. Unprocessed data, the data that have not been processed. And then from temporary, the data will be sent to ALU. So what is the purpose to send the data from the temporary to ALU? Just to process the data. Okay, what is the name of process? Arithmetic and logic. Okay, so now that is the process of loading or sending the data. Settle. Okay, now we go to the storing process. Okay, ataupun keeping process. So now the data is already processed by the ALU. Remember, the data that is already processed, we call it as a what?
Information or process data.
Yes, information or process data. Senang je kan? So that information or process data that has been processed okay, by the ALU will be sent to where? The first component that will receive the process data. Which component?
Memory.
Okay, temporary. Jawapan dia temporary. The answer is temporary. Before the process data or the information, before it will be sent to the memory, okay, the first component that will receive it, the first component is temporary. So temporary will keep two type of data. First, the unprocessed data. The second one is the information. That is the usage of temporary. Ada soalan tak? Is there any question? Belum selesai lagi, kita belum hantar lagi the information or process data back to the memory ya. We haven't yet reached that stage belum lagi. We just process the data. We just process the data and send it back the information or process data to temporary storage. Something like that. Okay, you got that? Faham tak? Okay, good. Okay, now
Yes,
the
sir.
information or process data is already in temporary. So what next? Okay, what next we need to refer to the step just now. There are 3 steps of storing. Okay, to store a value X to location A. See, location A means in the memory lah. So the first one, write the information to the MDR. Write the information or data X to the MDR, and then write the address into the MAR, and then control unit will send a write signal to memory. So it means when both register has content, which is MDR contain the information that the process data, while the MAR already has the registered address. So the third step is control unit will send the write signal to the memory. So when the signal is sent, so the data will be kept in the memory lah, based on the location, based on the address. Okay, that is the process of storing the information from CPU to the memory. Settle. Is there any question? Agak-agak kan? Boleh tak cerita balik? Can you guys tell me what is the process of loading? What do you understand, or how the process execute for loading process or for the storing process? Apa you boleh ceritakan pada saya? What you can tell me? Siapa yang nak test dia punya kefahaman, bolehlah cerita. Kalau salah saya boleh betulkan.
Untuk load ke sir?
Mana-mana pun boleh pilih. Saya tak minta terangkan semua. kita step by step. Setakat mana you all boleh cerita, nanti kita letak titik. So the next person dia akan sambung sampai habis, sampai dia simpan balik. Macam tu.
Saya cuba untuk load yang saya
Boleh.
yang saya faham mula-mula dekat MAR dia write address.
Dia tu siapa? Siapa yang tulis address tu?
Control unit.
Yes, control unit will write the address into MAR, betul. And then
Lepas tu control unit send read signal dekat memory. Lepas
Okay.
lepas tu data register.
Wait. Apa yang berlaku? What is happening during the second step tu?
Data registered dalam MDR.
Yes, data is registered into MDR. Okay, next.
Next, control unit read data daripada MDR ke CPU.
Okay, which part of CPU?
dekat temp
ICT.
Yes.
untuk store dalam
Oh,
CV.
yang kau ambil mana
Lepas
ICT?
tu dia
Cuk. Kenapa kena store sekejap dalam CPU? Saya tanya.
untuk ALU proses.
Yes, untuk ALU process the data. Good. Okay, next.
ALU proses undergo arithmetic and logic process.
Betul.
Lepas tu back to temp
Back to temp.
as information.
The process data or information back will be keep back to temp. Okay, next. Teruskan.
Dia lepas tu store punya proses pula.
Okay.
Uh,
Nampak gaya macam nak jawab seorang.
ada
Teruskan. Tapi it's okay. Kalau mampu.
orang lain rasa.
Okay, orang lain. Okay. This girl want to give
Main di
chance
sekolah,
to her friends to continue the process. Okay, now the information is already in temporary.
Main kali.
Damn.
Yang kita kena fast.
So what's next?
Dia mesti dah rebukan dia.
Next step is processed by ALU.
That one is already done.
Oh, okay.
I mean your friends stop at the information is already keep in the temporary. What's next?
Next step is write data to MDR.
Okay. From where? From where?
From temporary,
Okay. From who will write the data?
the control unit.
Yes. Okay, next.
Biasa aku mati awal. Dah tingkat.
Next,
Tingkat menang lah, tapi aku mati. So aku lembut.
write the address into MAR.
Who gonna write this address?
Buat tank pun ya. Tapi buat dia main
I
campak.
think control unit also.
Yes, true.
Tapi one shot.
And then
Fahmi troll. Fahmi lagi troll.
Last step.
Low barrier. Barrier tu apa?
Dia yang merah-merah tu kan.
just refer to the note.
So send write signal to memory.
Who send the signal?
The MAR.
Who send the signal?
Asal kerja aku bodoh sial.
Control unit also.
Oh, also control.
Also control unit. Also control unit. So what is happening after the write signal is sent to the memory? Okay. At this
Goes
stage,
to output.
sorry, no, wait. At this stage, the data, the address is already registered in MAR, while the information is already registered in MDR. And then the control unit will send the right signal. So what is happening next? The data is still in MDR, not in the memory. It's still in the MDR. So what's next? After the right signal is sent. MDR tu kecil saja, dia macam buku log, just a small part of a memory. So after right signal is sent by the control unit to memory, so what is happening to the data in the MDR? Ada siapa boleh sambung? Anyone can continue?
Store juga.
Apa dia?
Store.
Stored. Okay, stored from apa? Apa stored tu apa? Panjangkan sikit ayat.
Store dalam MDR.
MDR tu, MDR is not the storage. MDR tu macam buku log, register, buku daftar. So now, the data, the information is already registered. Dah daftar dah dalam buku. And then what's next?
Store dalam memory.
Store dalam memory lah. So after right signal is sent to the memory, the data that already registered in the MDR will be stored in the memory. Baru selesai. Macam awak nak masuk, when you want to come to the class, you already write your name on the attendance list, and suddenly you just stand in not get into the class. You just stand at the door. And so tak settle, the process is not settled down. So after you register your name, of course you want to get into the class. So same goes to this. After you register the data in the MDR, so of course you want to keep it in the memory. Are you guys get or understand what I'm trying to tell you?
Got it, sir.
How about
Understand,
others?
sir.
Apa dia? Maaflah telinga saya tak berapa dengar sangat. Yang lain macam mana? Boleh tak dapat?
Can, sir.
Can. Nurul Aisyah, okay.
Oi, kelas.
Macam mana kau berkunci senang? Kunci saya dapat.
Nurul Aisyah.
Ya Allah. Lengur sekali aku.
Okay, Nurul Yana boleh. Terima kasih. Nurul Aisyah, are you there? Tak apalah, mungkin dia pergi toilet kot Okay, yang, siapa lagi yang nak siapa lagi yang ada nama saya tak nampak ni Siti Hajar, okey.
Sir, saya tak faham yang untuk yang the store tu. Tadi sir ada sebut temporary. Yang tu temporary tu untuk dekat mana?
Untuk dekat mana? Tengok slide yang nombor 2 tu.
Tadi sir cakap ada temporary tu untuk keep data dengan keep information kan? Untuk
Betul.
store. Jadi yang tu selepas kita send a right signal ke?
Send sekejap. Okay, no, kejap, send a what signal? Read signal or right signal? Awak cakap apa tadi? Read ke right signal?
Send.
Send. No, I mean yang kata signal tadi tu awak sebut read ke right? Saya tak dengar.
Send a right signal.
Send a right signal. Okay, send a right signal ni, masa ni data dah ada dalam MDR. Bukan lagi dalam temporary. Awak tengok dekat the first step dalam store tu, dia ada 3 step. Dia kata write the data X to the MDR. So masa during the process write the data X to the MDR, what is happening is the data is already registered from temporary to MDR. Dah dalam MDR dah data tu. Dia bukan lagi dalam temporary. Dia dah dihantar balik ke MDR dah, cuma belum disimpan lagi dalam memory je. Kalau nak simpan dalam memory, dia kena tulis dulu alamat dalam memory, MAR, and then hantar write signal. Lepas hantar write signal, barulah data daripada MDR disimpan dalam memory. MDR dengan MAR ni dia macam buku register. Awak tahu tak buku register?
Tahu sir.
Macam awak nak pergi program kan kena daftar nama kan. Sebelum nak masuk program kena daftar nama. Jadi sebelum masukkan data atau sebelum simpan information dalam memory, kena daftar dulu alamat dan data tu. Bila dah daftar, barulah boleh disimpan dalam memory. So sebelum daftar ni data ni berada di mana? Untuk proses simpan.
CPU.
Which part of CPU? Part mana dalam CPU tu? CPU ada 2 komponen. Which part of the CPU? Komponen mana satu?
Temporary.
Temporary. Boleh tak Siti Hajar?
Boleh faham sir.
Siti Hajar pula. Temporary ni tempat untuk simpan sekejap. Maksudnya lepas proses, macam awak goreng ikan, sebelum awak letak atas, you just imagine the memory ni macam table makan. Your dining table. So nak makan atas table tu lah kan. So before you hidangkan makanan, you nak keluarkan daripada kuali. Kuali ni tempat proses. You goreng, you fried the fish, the chicken kan, you process it during the pan, using pan, guna kuali. So the pan is analogy for for the ALU. ALU tu kuali, masak. Sebelum awak hidang atas meja, which is memory, awak letak dulu dalam pinggan. So pinggan tu temporary lah, sekejap. Pinggan daripada kuali tu awak nak keluarkan makanan, letak dalam pinggan sebelum dihidang. Awak tak makan terus daripada kuali kan? So you're not just get the food from the pan. You need to transfer it on the plate before you serve it on the table. So the use of temporary component is similar like the plate. Dia nak simpan sekejap. Dia nak letak makanan tu, nak letak data. Before you fry the chicken pun, you will put the chicken on the plate or some boxes lah, container, before you put it, you fry it using pan, betul tak?
Betul.
Betul, sir.
So that is the process of that is the use of temporary. Dia macam nampak macam tak penting, tapi dia penting. Mana ada orang kat pinggan ikan or chicken, fried chicken from pan directly on the table kan. Orang tak makan atas meja. Orang akan letak atas pinggan dulu. Macam tu. So same goes to the process data or information. The information will be keep on the temporary for a while. Nama pun temporary kan. Temporary is sementara. For a while before the data is or information registered into MDR. Boleh tak Siti Hajah?
Okay, boleh. Thank you, sir.
Welcome. Sebenarnya mudah je, tak apa, tanya je siapa yang tak faham. Azrina, you okay?
Okay, sir.
Saya minta maaf sebab saya tak boleh sebut nama seorang-seorang, kata habis kelas kan. Yang mana saya nampak dalam list ni saya sebut je. Yang mana saya tak sebut tu saya minta maaf. Tapi kalau nak bertanya tak ada masalah, just raise up your hand. You can ask me any question. Okay, settle. So that is the process of load and store in the memory. Okay. Next, CPU. Okay, we talk about CPU. So CPU in the CPU, it has two component, sub-component lah. Sub-component. Sub ni maksudnya the things under the main one is component. Sub means the component in the main component. So that is what we call as a sub-component. So CPU, it has functional unit. So functional unit ni is a unit yang akan melaksanakan, the unit that will execute the arithmetic and logic process lah. So for arithmetic basically we have four process je. We have additional, subtraction, multiplication, division. But in this class we just learn about additional, only one process, arithmetic. And then logic, we learn about 5 types of gates. So this ALU can execute AND or not, NAND, nor additional. So that's it. So it's for ALU. For temporary, okay, what is temporary? Temporary is a small and temporary storage. It's a very small. It is not as big as memory or RAM. It's just very small storage, and it will keep the data just for temporary. Sekejap je. Okay. And what is the things that what is the type of data, or I mean what is the data that will be kept in the temporary? So there are two types of data. The first one is operand and the result. So what is operand? Operand ni is a sources. The sources of the operation. Operands and operation. Okay. Biasalah nak matang ni kita kena belajar banyak perkataan yang bombastic, you know. You need to learn about bombastic words. So operand is refer to the sources of the operation. Okay, what is the operation? The operation is additional, tambah tolak darab bagilah. Additional, subtraction, multiplication, division. Okay, that one is an operation. So operand is the sources. Let's say, I give you example. If we do the execute the arithmetic operation, 1 plus 2. For example, 1 plus 2. So plus is the operation. Plus is the operation. Okay, 1 and 2 are the sources or operands. Operand, 1 and 2 are operands, while the plus is the operation. Okay, faham tak?
Ambil kelai.
Dalam mana?
Tak.
Jogging lah. Jogging.
Bagi kat tali yang kau.
Dapat tak maksud operand? Means operand tu data lah. Data yang belum diproses.
Cukup kan kelai awal.
Susah bungok. Maksudnya dia tak habis.
Boleh tak?
Dia tak habiskan belajar. Lecturer video.
Faham, sir.
Tak tahu dia akan bagi ke tak. Dia kata minggu
So
depan.
data dalam temporary. Operasi dekat
Bintang
mana?
Valora.
Where's the location of operation? In the temporary or in the ALU?
Aku ish.
Teruk saya cikgu Mat.
ALU.
ALU lah. The operation is in
Terus saya
ALU
kena
because
maju.
ALU will do all the operation. But the data is in the temporary. So operand is in the temporary. So what is operand? Operand is data. So what is data? Data is the sources of the operation. So what is the sources of operation? The sources of the operation is, for example, 1 plus 2. So 1 and 2 is the sources, is the operand, is the data. While the plus operation is the operation in the ALU. Jangan confuse ya. And then after the data, both data or sources are sent to the ALU, the data will be processed and the result. So what is the another word that we can use to represent the result? Tadi banyak kali kita guna. The what? Information. So you can use result, you can use information. It depends on your understanding. So the information or the result is also will be kept in the temporary for short term before it is sent to memory. Semudah tu je. And then actually temporary, it has actually we have the CPU has 8 register, so means that temporary itself in the CPU there are 8 temporary storage, 8. So each of the storage, the size is 16 bit. So maknanya it means that in one process, in one cycle, at least 8 data or 8 data plus information lah, data plus and information can be kept in the temporary storage because it has 8 register, ada 8 ruang, 8 register, 8 spaces. So each of the registers, the size is 16 bit. So my question is, so what is the size of the overall size of temporary storage? What is the formula? Mudah tu lah. What is the formula? Jangan guna formula. Don't use the 2 and power of k times m. This one is just for general, just based on your logic. What is the size of the overall size of the temporary storage? How many bits that it can keep? Come on.
128.
No, I actually I don't want the answer. I want the how you calculate it.
16 kali 8 sir.
16 kali 8, 16 times 8. Yes. So 16 times 8 so that is the size of the temporary. So you can you can keep the data and information as much as that. 16 times 8 Okay. So you can see that the label of the register starting from 0 so don't confuse. So the end of the register, the maximum one is 7. 7 R7 mean the 8 register lah, because it's a label starting from 0. So for the 8 register, the label is R7 lah. Okay.
Takkan rugi kalau
Boleh
macam
tak?
kau apa tu kripto.
Can you get that? Understand what I'm trying to tell you?
Saham kan boleh ni rugi. Kalau yang SB ni kira saham tapi kau takkan rugi lah. Cuma pulangan tu sikit lah macam tu. 5% je.
Faham ke tidak? Kalau tak faham tanya.
Faham, sir.
Okay, thank you. Alright. Ni pun skor I always give this question in the class. I always always give this kind of question in the class. Okay, my question is, Okay.
Very slow though this.
Yeah.
Berikan satu contoh perkataan is give me one example of word. Berikan satu contoh perkataan. So apa yang awak boleh beritahu saya? Apa-apa saja yang terlintas, impromptu tak perlu fikir. Apa yang boleh saya cakap terus terlintas, apa dia?
Binary.
Give me one example. Contoh terus. Bukan maksud, contoh. Apa dia? Come on. Saya nak dengar awak punya idea. Kalau dekat sekolah, cikgu yang sampaikan maklumat. Di universiti, kita share kefahaman masing-masing. Jangan risau takut sebab apa? Sebab apa saya cakap jangan risau takut? Sebab kita ni ada 16 orang tau. There are 16 brain in this class. So this 16 brain has a lot of difference when we want to talk about one thing. So don't worry, everybody has its own opinions to answer my question. So don't worry, cakap je. So my question is very simple. So what is the, let's say in the exam I ask you, what is it? Give me one example of word. Apa yang awak nak jawab atas kertas? How can you answer this question? Satu contoh perkataan. Based on the notes, word size tu. There's a note, word size over there. Number of bits normally processed by ALU in one instruction. Also width of register, FC3 is 16 bit. So that is the hint of the answer. So what is the answer? Ni kalau dalam face to face class, I akan bagi duit RM1, RM2, kadang RM5 to those who can answer my teka-teki.
So, is it data?
No? No? Okay.
Sir, kena spell the words kah?
Whatever. Saya tak kisah awak nak buat apa. Saya cuma nak tahu je apa jawapan awak. Okay, tadi data. Okay, next. Give me one example of word. Berikan saya satu contoh perkataan. Jawab je apa-apa. Takkan seorang je kot. Bits. Okey, lagi. Kita ada 15 orang. Sekurang-kurangnya, termasuk saya 15. Okey, sekurang-kurangnya ada 7 jawapan. Separuh. Sebab soalan senang sangat. It's very easy question. Ding Ali, give me one example of word.
I'm trying to think. I'm not sure. I also want to say bits, but I'm not sure it's right or not.
Okay. Actually, for this question, I don't want you to use your brain. Okay? To all of you, to answer this question, I don't want you to use your brain. I just want you to answer based on your own feeling. Just, okay, logic. Just say it. Jangan terlalu berat. Don't think too much. Just relax ya. Ding Ali, just relax. So bits, logic, just now data, and then Number of bit word is a number of bits normally processed by ALU in one instruction.
Ada Excel.
Program ni.
Excel your interview with SPP.
Come on, I'm waiting. Nur Eliza, are you there?
Kau pakai Microsoft Excel.
Yes, sir.
Excel sebenarnya.
Macam mana? Apa pendapat awak? Kita sembang-sembang je. Apa awak rasa? Awak rasa takut ke saya sebut nama awak?
Takkan ke?
Tak.
Okay, bagus. Apa nak jawab kalau saya tanya soalan tu?
Komputer.
Komputer. Okey. Terima kasih. Okay, lagi? Orang lain pula.
Cakap apa-apa je ke?
Student Ali, what is the the example of the word? We have bytes, we have logic, bits, data, coding Ali, bytes. Ooh, bytes. Okay, good. Okay, memory. Okay, sama. Okay lah, we already 1, 2, 3, 4, 5 data just now, 6. One more, 7.
Sedar aja.
Ajar lain.
Macam-macam jawapan.
Aku cakap hajar.
Apa, it's okay, no problem. I can see the, like when I see the lot of answer here, I can see actually saya nampak macam bunga. RAM. This RAM is a flower, the red flower memory is a flower, another flower bites another flower. So I always see everything as a positive, in a positive way. Banyak. So I'm happy to look at the answer. I'm not judging you whether it's correct or wrong. I just want to see the flower from you. So we have RAM, we have memory, we have bytes, logic, bits. 1, 2, 3, 4, 5, 6. One more.
Habis. Cakap pasal private masa tu kan. Yang
Satu lagi, come on.
dia ada tambah cerita lagi. Dia tanya.
Jun Zian Lee.
Dia cakap dia boncen. Kata
Give me one example, dear. You are so quiet. So give me one example of word.
Dia cakap dulu dekat kampung aku ada ni, ada orang buat pakai reset.
Computer.
Tim reset itu dia buat.
Okay, write it down in the chat box.
Aku
Pelayan lah.
macam benda tu dia kata betul. Aku macam tak boleh benda macam yang dia buat. Tapi boleh dia buat. Tapi aku tak tahu macam tu. Aku macam
By 4 o'clock, we will take a break about 10 minutes, yeah.
Johor je
So
ada
we
barangan kan.
we will stop at 4 o'clock. Hexadecimal. Okay.
Tak tahu juga.
Kan depan dia ada lah.
Ada yang bawa motor rempit-rempit macam tu.
Okay, Jun Zanli, don't you want to write down your answer in the chat box?
Enggak.
Mana barang apa raya?
Wait teacher.
Okay.
Tukar exhaust sebab kampung kan. Tukar exhaust bagi kuat.
Semua tempat ada. Semua tempat
Semua tempat ada.
Lagi
Sebab
dekat dengan Thailand tu. Lagi dekat dengan Thailand ni banyak.
sebab tengok baca dekat tu social media banyak Johor je.
Banyak.
Pahang ada.
Pahang
Lagi
ada.
rumah ke rumah. Satu kampung. Apa? Tak habis. Ya ikut habis.
Kalau aku cakap ni boleh buat exhaust, kau mesti bangga kan?
Terbakar bodoh. Water reset tu at least dia aluminium. Tin.
Tin lah ni.
Jun Zanli, are you there?
Besi lembut.
Buat
Okay, Hadis. So thank you very much, Jun Zanli. I love to see you.
Yeah.
Okay,
teacher.
okay, thank you. I love to see your reaction or your response. Thank you very much for participating in this in the class. Okay, guys. Let's say I write this. Yeah, I will write something in the chat box. Wait.
dia kata dah balik Seramat.
You see that? Nampak tak?
Nampak?
Okay.
Yes.
Okay. Okay, good. How many bits that I write there? That I wrote there?
How many bits?
16.
16.
Mana?
16,
Tu.
16 bits, 0 and 1. Yes, 16. So back to the notes. Okay, thank you, Jun Zanli, Doriana, Vignesh, thank you. So look at the notes just now. Okay, word size. The definition of it is, okay, number of bits normally processed by ALU in one instruction. Number of bits normally processed by ALU in one instruction. So you know that ALU will process 0 and 1. So how many 0 and 1 that will be processed in one single time? So the answer is 16. So in one single time, the ALU can process 16 bit or one word. 16 bit means one word. So the question just now is, give me an example of a word. Okay, of a word. So I give this my answer 01010101000111. So this is the example of word. Because word means 16 bit. So any kind of any arrangement, sequence doesn't matter. The thing is, it must have 16 bit. So if you have 16 bit, you can call it as a word. So in this course, the word means 16 bits. So your answer just now, hadis, hexadecimal, whatsoever, okay, that one is a word in bahasa class, in a language class. If I ask you, give me one example of word, you can say any kind of word. So maybe in my class, you give the, I can see that you give me the example like this hexadecimal RAM actually. Okay, all of this word actually is referred to this course. You see how the people thinks, how the brain works. This thing is fun, you know. That's why I tell you, I told you just now. I when you give me the answer, I can see the flower inside it. You know what I mean? What I mean is, if I give the same question to bahasa, to language student, let's say I ask them, what is the example of word? Of course, they can give me a lot of word based on their course. And you guys, when I ask you the same question, I can see the answer is in the context of computer. See, logic, bytes, bit, memory, RAM, hexa, hard disk. See how the human brains work. Kan? Actually, human brains is work in the scope. It's natural process. We will think in the scope. We will not think outside the scope. It's a normal process. Sebab because why is this happen? This is happen because we have our own background. Junzianli has its own background. Anis has its own background. So if I ask the same question to each of you, you will answer this question based on your own background. So it's a lot of answer. So same to these things, this question. Now I ask you as your background is this minor, I mean IT minor. So when I ask you the same question, like I asked to the other student in another course, so you will give the answer is basically in the IT scope. That's why you give RAM, memory, bytes, logic. See, so it's a normal process, and I'm not saying it is wrong. It is correct, but to be specific in this course, when we talk about word means size. So word equal to 16 bits. So if you see anything that contains 16 bit, I mean 16 of 0 plus 1, 0 and 1. So if it is 16 bit, so you can call it as one word. One word. Okay, let's say if you can see 32 bits of 0 and 1. So what you can call that sequence if 32 bits? What you can call 32 bits?
Two-word.
Two words, yes, two words. Two words atau or IEEE 7794 tak silap saya. Ingat tak IEEE before this yang ada point, floating point tu? The floating point question kan panjang jawapan dia kan, 32 bit kan, yang ada exponent, ada fraction. Do you remember that? Still remember that?
Yes.
So that 32 bits you can call it as a two words or IEEE 794. So what if you only have 16 divided by 2, 8 bit? What terms that we can use to refer to the 8 bits of sequence of number?
Half word.
Half word or byte. B-Y-T-E, byte. So half word boleh, byte boleh. So 8 bit equal to 1 byte or half word. 16 bit equal to 1 word. 32 bit equal to 2 words or IEEE something. Okay. So for if you have 4 bit, we name it as a nibble. N-I-B-L-L-E. Okay, nibble. I type there, nibble. Okay. So one word means 16 bit. The sequence of 1 0 and 1, and it has 16 bit. So not the normal word like you give me just now, all the hexa, computer, whatsoever. That one is an example of word in bahasa class, in the language class. But in this class, the 16 bit of number is called as a word. So if I ask you to give an example, just give me any sequence of number, but the size is 16 bit. Only that. Okay? Can you get that, guys?
Yes, sir.
Yes, sir.
Okay, thank you very much. Okay, next we go to the next slide. Okay, we already we already learned about memory and CPU. Okay, next it's become easier lah. Input and output. So if I told just now, the input and output can be listed out based on the type of data. So if you still remember, how many types of data that we have?
5.
5. Okay, settle. 5. Okay, good. So, for input device or output device, actually, like memory, it has its own register, MAR and MDR. Okay, for your information, it's similar for input and output device, where input and output device also has its own register. So if you want to use the input and output device, actually, the data that you key in from input, or you want to take it out using output, actually, it has its own register. Need to be registered somewhere before the data is used. So for input, like keyboard, it has KBDR and KBSR. KBDR stands for data, and KBSR stands for status. It is not referred to address. Like memory, it has address register, but for output and output and input, there's no address register. It has status register. Why? It is because input and output is not a memory. Ingat please remember. Do remember. In memory, it has address and data, and the use of address is to locate the location in the memory. This is your friend answer. Your friend give me this answer. So because of the keyboard and monitor is not a memory, it is an input and output. Kelakar lah pula if you said that keyboard has memory. You never find that keyboard has memory. And you never, please don't go to the IT shop and say, can I buy the RAM for keyboard? Don't say that. RAM is for computer, not for keyboard, or not for speaker. Can I buy a RAM for speaker? Pelik kan? It look weird. Can I buy a RAM for microphone? Kan pelik tu. So there is no address for this both input and output. So that is why the register that used for these both peripherals or devices is status register. Same goes to the output. Like monitor, it has its own data display data register (DDR) or display status register. And do realize that some of the devices or peripheral also can be classified as an input or an output. The example is disk and network or USB. Maybe USB just now we talk about USB. USB apa nama tu? Flash memory tu, flash memory. So this hard disk, network, flash memory is also can be defined as an input and output based on its usage on that particular time. Okay, that's it. Okay, the last sentence you just ignore it. Okay, now we already touched about memory, CPU, and input and output. And the last one is control unit. The control unit. So this is the last one for the von Neumann model. So the function of control unit to orchestrate execution of the program. To orchestrate, to make it synchronize. Kena synchronize because if you want to use input, it must be synchronized. That is why when you talk using computer, your voice will be a project, or the output for your voice is speaker. You never see, you never find that if you talk using microphone, then the output is monitor.
Tak kena lah.
It's impossible. It's impossible. Awak bercakap dengan mikrofon, suara awak keluar ikut display. It's impossible. If you use microphone, the output must be speaker. So, who control this? This one need to be controlled. Computer is not intelligent. We as a human, we are intelligent. We teach computer what to do. If computer get data from microphone, so the computer must send the data. If the computer want to to get out to bring out the data, the computer must use speaker. So all of these things is set up by the human, not by the computer. That's why people say human is intelligent than computer. Computer just do whatever we give them. Okay. So the function of control unit is to orchestrate execution of the program. So if you want to use the microphone as an input, the output must be speaker. So all of this synchronization or orchestrate station is done by the control unit. Gitu. So in the control unit, it has two subcomponent, PC and IR. So what is PC? Okay, what is IR? IR contains the current instruction. Instruction ni means data lah, data or information. Instruction contains data and information. So we combine it both. We use the terms instruction, arahan. So arahan yang hendak diproses, or the arahan or the instruction that will be processed, I mean the data and the information lah that will be processed, will be kept in the instruction register. Means that the data will be sent to the instruction to the control unit. And control unit will read the instruction, will interpret, and then it will orchestrate the information with temporary, with ALU, with MAR, with MDR. So maknanya dia nanti awak akan tengok later, you can see how does the instruction looks like. So from the instruction, control unit will tell memory unit what to do, control unit will tell CPU what to do, or just based on the instruction. Like we learned just now earlier, data is sent from memory to CPU and then will be processed and returned back to the memory in the form of information. And control unit will send the read signal, will send the write signal. So actually what is happening? Sebenarnya apa yang berlaku bila kita sebut ni tadi? So what is happening when we talk about this? So actually what is happening is the control unit will read the information in the instruction. The information is in the instruction. I mean not information, the arahan, the operand, Everything is in the instruction. So control unit need to define or need to, apa orang kata dia kena, can you imagine I give you instruction 01010101000111. So what you can interpret that instruction? How can you interpret the instruction? So control unit will interpret the instruction, and after the control unit already interpret the definition or the meaning of the instruction, it will tells memory what to do. It will tells CPU what to do, input what to do, control unit what output what to do. So it depends on how the control unit translate or interpret the instruction. Nanti awak akan tengok. Later you can see the architecture. That is the where our subject name came from. Okay, this is the part, the core of the program. So you can see the architecture of the instruction. Do remember one instruction 16-bit. So macam mana, how this computer can send instruction, can send operand, can send operand, instruction, information, data only by using 16-bit. Special Dia boleh hantar maklumat guna 16-bit saja. We can see it later. Don't worry. And then so that instruction will be will be translate or will be interpret by the instruction register lah, control unit. And then PC ni contains the address of next instruction to be executed. Okay, maybe you are not clear about this, but never mind. In the next chapter we learn deeply about this. Nanti awak tak nampak pelik dah benda ni. You will get familiar with this term. And then okay. You can see the below part there. Control unit, okay, read an instruction from memory. See? Read an instruction. Okay. So means that the instruction contains data. The instruction contains data and also the operation. The what to do. So the instruction address in the PC, never mind. Okay, interpret the instruction. Control unit will interpret the instruction, generating signal that tell the other components what to do. So that is the function of control unit. Never mind, I will let you know. I will teach you how to interpret the instruction. Just using manual, using paper and pen, you can translate the information. You can translate the instruction manually. Nanti awak kelas awak pandai nanti. So don't worry. This is just for the beginning. I will tell you later. I will teach you later how to interpret the 16-bit of instruction into one instruction that we as a human understand what to do. Macam tu. Don't worry. So basically the process that we have learned just now, take out the data, the loading and the storing process actually can be drawn or can be expressed or can be presented into instruction processing flow diagram, flowchart. Diagram aliran ni. Flowchart. So what is the first step? Okay, fetch instruction from memory. Control unit will fetch instruction from memory, and then the instruction, the fetch instruction will be interpret by the IR, by the control unit. IR in the control unit, and then after the instruction is interpret. So in the instruction itself, it has address. So the third step is valued address, and then once the address is evaluated or calculated, so we know the data lah, where's the location of the data lah, because we already have the address. And then once we know about the location, we just direct straightly fetch the operands from memory or fetch the data from the memory. And then once we get the data, so we just execute operation. CPU will operate the operation, and after the operation is finished, so the result or the information we will send back to, will be stored into memory. And this process is cycle. You can see the cycle. It never stop. Starting from you switch on the computer until you switch off the computer. So the process never stop. Okay. What is the instruction? Okay, like I said just now, in the instruction itself, the size is 16-bit, and in the instruction it has opcode and operand. Operand, I already tell you what is operand means. I mean the data or the location, like 1 plus 2, 1 and 2 is a data lah, or operands. So what is opcode? Opcode ni is an operation to be performed, or operation lah, or operation. We have 4 operation for arithmetic and 5 operation at least for logic. So all of this operation has its own special code. Why we use code? Because computer only recognize 0 and 1. So how control unit can tell computer what to do, either logic or okay computer or like ALU. Let's say control unit send the instruction to the ALU. Let's say the control unit want ALU to do additional operation. So what is the code that can be used? So dia ada code dia, special code. For add a special code, multiplication ada special code, not ada special code. So by using this code, so control unit can tell other component what to do lah. Never mind, I will show you how does the instruction look like. Dalam soalan exam before, in the exam question, in the exam question, we have ISA table. Before we stop at this slide, okay, I will show you how the opcode and operands look. How does it look in the instruction? Actually, we have one table. This table will be given in the exam. So don't worry. Sebab we won't ask you to understand or to memorize the architecture of the instruction. So don't worry, I will give you the table, and your task is just to understand the table, and then how to use the table. Sekejap. ISA table, pad and petal. Saya tengah Google ni ISA table. Tak apa, saya Kejap lagi kita berhenti sekejap lagi. Kejap lagi, sabar. Awak nampak apa dekat skrin sekarang?
Nampak slide sir.
Okey. Sebab saya tengah buka soalan exam ni. So saya tanya sekejap. Saya tengah buka soalan exam. Saya nak ambil table yang saya nak tunjuk kat awak, table architecture, instruction architecture ni. Sebab dalam nota kata dalam instruction, in the instruction it has opcode and apa tadi? Alamak.
Operand sir.
Opcode dengan operand. So how does it looks in the instruction? So I'll give you the architecture. Sekejap kita rehat lah, sebab saya pun tak solat zuhur lagi, saya tak makan lagi. Perut saya bunyi-bunyi dah. Sekejap nak berhenti 15 minit pun boleh, sempat lah nak makan ke ni pun dah banyak lah kita belajar petang ni. Okey lah. Okey, saya akan tunjukkan pada awak save as paper. ISA table. Okay. So ini contoh ISA table. Apa dia opcode? Kat mana opcode? Kat mana operand? Where is the location of opcode and operand in the instruction? Okay. I already have the table. Okay, saya tunjukkan dekat awak sekarang sebelum kita berhenti rehat. Okay, nampak tak? ISA table.
We build this house of memories. Take my picture now. Shake it to the sea. Wah, tak saying dia. Oh, percent. What? Oh, the last, right. Alamak, sir.
Nampak tak?
sir.
Fatih Nabilah nampak tak?
Nampak sir.
Satu-satu tak apalah saya sebut lah. Muhammad Hafizuddin nampak?
Nampak, sir.
Hafiz nampak tak?
Nampak.
Korang ni kan kalau saya kau tak panggil lah. Anis Natasha nampak tak? Anis nampak?
Nampak.
Empat. Siapa lagi saya nak sebut? Muhammad Firdaus nampak? Mana Muhammad Firdaus ni?
Jadi mana nampak sekali. Kita dah buat tu macam ni.
Korang janganlah lari, penat. Saya tak makan lagi tau. Betul-betul semua saya nak bagi nak deliver content. Suddenly korang pun tak sudi nak tengok sedih lah saya. Nampak bagus Muhammad Firdaus. Ada pun. Maizatul Syuhaida nampak?
Me after slamming to the one cup of others.
Nampak.
Kenapa bodoh buat?
Sekejap lagi. Kita tunggu sikit dulu. Check asal masuk pukul berapa. 4.5. Okay. So okay. Kalau tengok table ni, saya besarkan sikit. Awak tengok. Contoh macam add kan? Add ni arithmetic. Add ni arithmetic lah. Ada dua add kat sini. So opcode. Kalau tengok, if you can see here, okay, this is instruction. Let's say the first two instruction is for add. Add is arithmetic lah. And then the next two is for n. N is logic. Okay, this is for example lah. Don't look the below one, the below instruction, just for the top four here. Okay, so 2 for add and 2 for n. Add is for arithmetic and n is for logic. You can see the size of the instruction is 16 bit, starting from 0 to 15. Nampak tak?
Kalau dia panggil aku, cakap ada.
Nampak.
Okay, so the size is 16 and you can see a bit 12 and until 15, it has 4 bit over there. 12, 13, 14, 15. Can you see that?
Yes sir.
Okay, that one is opcode or operation. Code for operation lah, opcode. Code operation, operation code. So 0001 means the control unit asks the CPU to do additional process. Let's say control unit said send signal 0001. So it means CPU must do additional process. Let's say the control unit asks CPU to do 0101. Okay, 0101 means N. Let's say the control unit asks control unit to do mana dia ya? Not. Okay. 1001. 1001 means not. Okay, that is what we call as opcode, operation code. So there is 4 bit for opcode. So okay, and then we take the first example here. So bit 11, 9 to 11 DR, 6 to 8 is SR1, and then we have 000. That one is standard, and then we have 0 to 2. 3 bits. You can see there SR1, SR2 and DR. Okay, SR means source register. So in this register it has data. Same goes to SR2, register number 2, it has data. So DR is the register to keep the process. Okay, let's say the instruction is, let's say 0001, the first one 0001, and then for DR is 001. Remember, write on the piece of paper in front of you. Please write this. I repeat. Okay, let's say we take the first instruction as an example. Tulis. Okay, let's say the instruction is 0001, and then 001, and then 010, and then 000, and then 100. Dapat tak? Sempat tulis? Ke tak tulis?
Lagi sekali, sir.
Okay,
Tak
zero-
sempat.
Okey, tak apa. 0001 ini yang nombor 1 Kita ambil contoh nombor 1. 0001 and then 001 dah.
Dah, sir.
Okey, kemudian 010 dah.
Dah, sir.
Kemudian 000 lah. Bit 3 hingga 5 tu 000 itu standard. Dah.
Dah, sir.
Lepas tu 100. Okey. Dah.
Dah, sir.
Okay. Everybody got enough time to jot down the word just now?
Yes.
Okay. So 0001 and then 001 and then 101 and then 000 and then 100. Okay, this is the word 16 bit. So what does it mean? Let's say control unit has got this instruction. So how this control unit tells other component what to do? So control unit need to interpret this instruction. So how to interpret it? By using the table just now. So 001 means add. So put add over there. Add. This is using our own language to understand. We're trying to understand what control unit trying to understand. Macam tu. So the first source SR1, I mean the first operand. Where is the location of the first operand? The first operand is in 0010, right? I mean the green one. This is SR1, isn't it? This one SR1, isn't it? 0 to 2 is SR2. And then DR is 001. Okay, so 001 is add. So SR1 is the green one. So the first operand located in the register number 2. 010 means 2 012 is 010 is 2, and then the second operand located in the register number 4. Remember, we have 8 register in temporary, starting from R0 to R7. So please, all of these register will be used, okay, regularly. So for this step, for this instruction, for this example, the first operand is located in R2. The second one is in R4 because 100 is 4, right? In arithmetic, we have learned 100 is 4, 010 is 2. So this operand, the operand in R2 will be add with to the operand in R4 and will be keep like that. Will be keep in destination. Destination is the place where the operation will be, the result of the operation will be kept lah. So the red one is R what? 001 is R. Come on, 010 is R2, 100 is R4. So I already give you 2 examples. So 001 is, the red one is
1.
R1. So the process or the result of the content of R2 add with the content with R4, the result will be kept in R1. So this is temporary lah, the register in temporary. So this this process is execute in in CPU lah, because it is additional kan, additional. 001 is additional, add. So add is 001 is add. So the component that involved is, apa komponen terlibat? Where's the component involved in the additional process? Memory ke, CPU ke, input ke, output ke, control unit?
CPU.
CPU. So CPU. So this process is happening in CPU. So it means R1, R2, R4, everything is in CPU. In temporary lah. So this is how the control unit understand the instruction given to him, to it lah. So this is instruction given to it, and how the control unit interpret the instruction. So this is how the control unit interpret the instruction. So in exam, this is called as a comment. So if the question asks you to give a comment, so this is how the comment looks like. I mean the structure of the content. R2 plus R4 keep in R1. Something like that lah. So this is for add, the example of add. After this, I will let you know about the end, and then so on lah. So we'll take a 15-minute breaks, and then you can see the ISA table here, or maybe you can Google and download it from internet. Use the keyword ISA table, pet and cradle. You can see, you can find out, or you can find this table in the internet. So we'll stop 15 minutes, ya. Boleh?
Boleh, sir.
Okay, thank you very much.
Video belau. Video belau. Tahu? Senyap. Kuat siapa bau ni? Apa? Ini naik kau? Kau pakai shampoo ke? Haa. Campur shampoo bunyi pelik tu. Dah, shampoo aku tukar jenis wangi punya. Ni Man. Man. Gosok-gosok tak ni. Tunggu. Gosok pahang kat badan tak load. Foto apa ni? Ali cerak. Telah space. Aku suruh buat tak silap. Dah, ada seminit apa hati. Ha? Dekat ni macam ni. Takkan nak pakai KH siap. Apa? Takkan nak pakai baju KH. Pakai je lah. Baju KH jaga je. Dah baru ni. Ni kan baru ni limited punya. Logo bulat. Salah ni, string. Dah. Logo ni mula kata okey. Lepas tu tiba-tiba kata okey lah. Dah tukar logo lagi. Yang paling baru tu yang di warna kuning tu. Kira baju limited lah. Kalau kau jual mahal kan kat bundle. Dalam Malaysia berapa orang je ada?
Kalau gitu jual baju Neko mahal juga.
Mahal. Tapi design tu dah ada kan. tak limited lah. Kuatnya bau. Mandi tak bau.
Tak mandi.
Macam bau lagi lama gila. Yang betul-betul 3 hari baru hilang bau dia ni.
Ha?
Yang betul-betul 3 hari baru hilang.
Ibu masuk hari ini 15 years old. Dia waktu tanya anak, ibu tekan jawab anak saya dan tangis datang dari datang.
Dia bau kipas bau dia turun. Kalau bau ni nampak mesti nampak warna coklat. Macam tai.
Okey.
Orang kata dia jadi tai.
Okey.
Main basah maju tu. Sejak bau ini. Bau pelik. This house of memories, take my picture now, shake it to the sea. Harus sembah. Nanti aku balik KL, Jambang lah.
Okey.
Nak tanya Ian ni, betapa kat Taman Bata?
Nampak pun dia buat.
Nampak apa?
Tapi okey sikit kan dia pakai baju macam ni.
Nampak apa?
Tak adalah nampak ketat. Nampak perut.
Kes yang lembut. Nak pun tak buat minggu. Jumpa Subway Surf. Login lah Facebook.
Terima kasih.
Wan.
Terima kasih.
Okay Wan. Ramai baru hantar video juga kan. 3 minute challenge tu.
Betul. Saya kat dia main dulu.
Cepat kan, cepat je kan.
Lapan tambah 5 buat 13.
Oi, aku dah tengah buat ni. Lupa pula.
Oh ya.
Aku tengah screen record. Lupa. Tak boleh buka online.
Ready tak apa? Ready tak apa?
Kelas ni
Kelas apa BM?
MTN.
So hi guys, I'm back. Are you still there?
So,
Yes, sir. Yes, sir.
Yes,
Yes, sir.
Oh, very good, very good, very good. I'm so happy. Okay, so I already sent to you the ISA table through WhatsApp, so you can print it out if you want to look deep into it. So okay, actually, maybe you can jot down somewhere lah. So in this class, okay, before that, if you look at the ISA table, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 instruction. 20 instruction set. But in our class, we are not going to use all of these 20 instruction. So please jot down the instruction that will be learned in this class. Okay, the first one is these two add. I tell you the instruction that will be learned in this class. So these two add. Dah tanda dah? Or jot down something somewhere lah. Jot down somewhere the instruction that will be used in this class. Dah ready? Are you ready?
Yes, sir. Yes, sir.
Okay. 2 add 2n br and then ld ldi ldr lea not st sti str trap. Only that instruction. Okay, so next what we're going to do is how to translate or interpret this instruction by writing out the comments lah. So you kena tahu, you need to know how to write the comment for the instruction. So never mind, we will learn about it. So you can get the list of the instruction just now, or you need me to repeat it again?
Repeat, sir.
Okay, to add 2n br. Okay, then we have five instruction, and then LD, LDR, all D here, LD, LDI, LDR, LEA, all D. So now we have 9, and then not, so we have 10, and then all these 3 ST, so we have 13, and then trap, so we have 14 instructions. So you need to know how to write down the command or how to interpret these 14 instruction. Okay, boleh dapat? Get that?
Dapat, sir.
Alright. So back to our notes. In the slide itself, it's already have all comments actually. You just need to study the slide. You just study the slide. You know how to write the comment. Not as hard as what you think. Senang je sebenarnya. Wait for a minute. That. Okay. So okay, slide 10. Okay, opcode. We already learned about opcode. The 4-bit, the last 4-bit, bit 11 until bit 15, and then operands. Operand is sources that contains in the register. So remember, we have 7 registers starting from R0 until R7. So okay, that's it. Okay, this is example of add instruction. So add, and then we have destination DR, and then we have source 1 and source 2. So let's say the example of the instruction is this one, 0001 110 010 00110. So in a sentence, we can say that add the content of R2. R2 is the first source, which is this one, bit 6 until bit 8. We have R2 here, and then add the content of R2 to the content of R6. R6 is the second source, which is this one, bit 0 until bit 2, and then store the result in R6. R6 is destination register, which is bit 9 until bit 11. Okay, this is how we write the comment in sentence form. If you don't want to write it in the sentence form, you can write it using the symbol that I showed just now. So for this case, R2 plus the content of R2 plus the content of R6, and we keep it or store it in R6. Okay. So the latest content of R6 is the result lah. So what does it mean? It means one register can be used many times. In the example, it shows you how R6 is being used for 2 times. The first one is to keep the operand. This one, the first one is keep the operand, but the second one, R6 will be used to keep the result of the additional operation. See, it used the same register twice, but the latest value after all operation ended, the latest value of R6 is the result or the result of the additional process. Betul tak? Can you get that? Let's say dalam R6 ni mula-mula, let's say at first stage R6 contain 2 while R2 contain 1. So the value of R2 is equal to 1 and the content of R6 is equal to 2. For example, so 1 plus 2 is 3. So 3 will be kept in R6. So the early value of R6 is 2 while the recent value of R6 is 3 or 2.
3.
It means the content of register is always changing. always changing. Every second, the value of register is always changing. So we can trace the value one by one. Computer, when you start the computer, when you push the on button, the register will be changing until you switch off your computer. So that is why if your computer is stuck, so you need to switch off the computer for 10 seconds just to refresh the memory or register, because sometimes it got stuck. Maybe because of I don't know, maybe because of the component problem whatsoever. But it's happened because the register or the memory is used so many times. Because the number of register is limit. We only have 8 register, but computer need to do a lot of calculation. So of course we need to recycle register so many times. If one, let's say the register cannot be recycled, can you imagine how much is the price of the computer? Let's say one memory costs about 100 something. If you want to add 100 memory, so how many thousand you need to spend just for memory, just for RAM? So that is why the register or the RAM can be recycled. I mean the content in the RAM or register can be renewed each of the second, every minute. So in this case, at the first, the earliest stage, R6 contains 2, but recently the end value, the last value, the final value of R6 is 1 plus 2, which is 3. Faham tak? Do you understand what I'm talking about? Okay, yang lain?
Yes, sir.
Siti Hajar.
Faham, sir.
Siti Hajar ni semester 1 ya, kawan-kawan. The student baru first semester, so saya kena fokus sikit dekat dia lah. Okay, and then this one is for LDR. Oh, before that, for add opcode 001 or operational add operation. Okay, to your opinion, let's say we have 5 components in von Neumann model. We have input, output, memory, CPU and control unit, kan? So for add, let's say only 5 component lah without control units, because control unit is just for the controller, kan? So either input, output, memory or CPU. For add process, to your opinion, which component involved in this process? Either input, output, memory or CPU. Which component?
CPU.
CPU. Yang ni saya highlight because I highlight this because some of the opcode involve more than one component. That's why I highlight this early. So add only involve CPU. Okay. This one LDR. Okay, LDR ni actually the instruction that asks that the instruction that used by the control unit to tell memory so that the content of the memory can be sent to CPU. L means load. LDI, LDR, there are 4 type of L. LD, LDI, LDR, LEA. You can see the IC table just now. There are 4 L starting from L means load. So there is 4 technique to load or to send data from memory to CPU, or precisely from memory to temporary lah. Itu yang lebih ringkas for the detail one. But in general, there are 4 types or method that can be used to send or to load data from memory to CPU. Macam tu. So LDR is one of it. So you can see here, let's say the control unit accept this type or this example of instruction, which is 0110, 010, 011, 000, 110. So let's look at the ISA table. So what does it mean? Okay, LDR. I'll show you the ISA table. Don't worry, we are already reached the end of the class. Don't worry. This is just for the conclusion lah. Okay, sekejap. I say table LDR ya. We will look at the LDR. Primula, are you there?
Sir.
Okay, good. Okay, LDR ya. LDR. Okay, here. You see 0110. Destination 3 bit for destination ni register, and then we have base R and offset 6. So what does it mean? Okay, base R and offset 6 means they are 6 bit 1, 2, 3, 4, 5, 6. Offset mean jarak, distance Okay, how to interpret this instruction So it's already in the notes, don't worry So add the value of 6. The value of 6 is here, offset 6 0, 0, 0, 1, 1, 0. 0, 0, 1, 1, 0, 4 plus 2 if you remember the arithmetic sequence 1, 2, 4, 8, 16, 32 that I asked you to remember early of this semester. So 0, 0, 0, 1, 1, 0 means 6. Offset 6 So add 6 to the content of R3. R3 is here. R3 is here. This is base R So register 3 got something, address, and add 6, this offset to the content or the address in R3 to form a memory address. See? To form the memory address that need to be registered in MAR. If you still remember the process of load, the first thing is to register the address into MAR. So this is how to form an address and register it in MAR. And then next, load the content of that memory location. Okay, load the content of that memory location, which is R3 plus 6. We got the new address and register the address in the MAR. And then load the content of that memory location to R2. So we load the content of that memory location to R2. R2 is destination, this one, 010. So in this case, to your opinion, where is the location of R2? Is it in the CPU or in memory? Dekat mana? Remember, LDR is a process of loading, sending. It's different with add. Add just now is only involve CPU because it is add and process, add operation. But this one is LDR, the way how we send the data from the memory to CPU. So in your opinion, where is the location of R2? Is it represent MDR? Or is it represent temporary? Come on, only two choice.
Temporary.
So it means this instruction will let the content of memory location. Okay, the content of that memory location lah. The calculation, how to calculate the address or memory location, we just need to add the content of R3 to R6. This is how to calculate the address. And then take out the content from memory and send it to load means send the content of that memory location in the memory lah ni. This one is in the memory to R2. To temporary lah.
Cari
so settle now with this instruction. The control unit can tell memory to send the data at the specific location, which is 3 plus 6. Load that or send that content to R2 with 2 temporary. So now the data is already taken out from the memory to CPU. Nampak tak? Can you see that after the content is already taken out from the memory to CPU, next we can do lah either add, or not. It's a continuous process. The first step need to load or send all the data from memory to CPU. So this is the technique, and then process data using add, not or and 3 and and then after finish process, send it back to the memory using store technique. If you look at the ISA table, there are 3 method of storing. Settle.
3 tahun.
So if you understand this,
Kita nak
so
bela
you
rambut
already
panjang
know
ke?
how the
Mana nak
data, the
jaga.
computer process data from memory to
Aku ni
CPU,
nak bela
and then
nak buat
process
timer ni.
and return back or keep it or store it in memory.
Siapa nama dia?
So there is 4
Ronald.
technique of sending or
Ryan
loading the
Ronald.
data,
Ronald.
and then the
Ryan
operation we
Ronald.
only have 3, either add, and or not. We're not going to use other than this. Don't worry, only 3, and then we can keep the result into memory using 4 technique. So 3 load, 4 loading, 2 operation, 3 storing. You can see the apa nama, the IC table there are ST, STR, STI. So 3 types. Like loading, we have LD, LDI, LDR and LEA. So 4 types of loading. So any question, kalau tak faham tolong tanya. Please ask me if you are not understand. Kesian awak Saya kesian sebenarnya. Saya tak nak. Saya tanya bukan sebab I don't mean to push you ya guys. I don't mean to push you. I just want to validate my assumption. Is it correct what I'm thinking towards you? Let's say I think that you understand this, but I need a validation from you. So if you say nothing, so I don't get the validation. Either you understand it or not. So the things will become blur. That is why communication skill is important. Okay. So kalau tak faham, if you understand, just let me know you got it. If not, also let me know so I can get the validation. So now, do you understand? Honestly, you tak faham. So which part you tak faham? There are two example. Okay, the first one is add. The second one is loading. So which one you are not understand? Or you don't know what is your task in this process? Let's say in the exam, what you need to do? Ke macam tu? Apa yang you tak faham? Jing Ali clear.
Lupa.
What you need to do? Anis, let's say I give you, I give you one thing okay. What you need to do kan? Okay, no problem. Okay, I give you this. Senang praktikal terus kan? Terus praktikal. Okay.
Saya masak rendang.
I give you this.
Rendam. Apa?
Yang lain macam mana yang lain selain pada Anis?
Susah saya tak
Understand, sir.
Okay. Yang lain? Saya semangat nak buat ngajar ni.
Kau dengan Zina je ke?
Untuk saya, untuk you all nanti dalam exam korang kena buat buat saya.
Dan kata ambil break.
Okay Anis, let's say I give you this.
Malas. Susah.
Apa yang awak boleh komen tentang ini?
Azrina ikut
Apa yang arahan ni buat? What is this instruction trying to do?
Boleh ambil kimia. Ambil baik.
Macam mana awak nak bagi tahu saya? How do you want to tell me what this instruction do? You need to, I give you the answer ya. You need to write a comment. Write a comment. So how to write the comment? There are 2 way. Satu, guna simbol macam ni. You can use this kind of technique. Or you write a sentence like in the slide. The slide kan dia tulis panjang-panjang. Add the content of R2 to R6. Keep in blah blah blah. You can also write a comment in that method. But I prefer this one because this one symbol is shorter. So easy to understand. So please write a comment for this instruction. Okay, cuba buat.
Screen protector
Tulis dalam.
Dah pecah dah.
You can write this in the chat box.
Lah benda murah siap RM5 lah. RM5 3 kopang.
This one is
Tengoklah
for add,
komen.
bukan untuk load lain.
Ada
Load tu
Syamil.
ambil, add ni proses. Okay.
Like lah.
Dah?
Ada 2 orang yang like kan, jambung kawan. Aku orang first.
Okay kan.
Ada kelas pukul 5 ya, okay tak apa. So kita end up this class. So untuk siapa yang tak ada kelas boleh tunggu sekejap, yang tak ada boleh keluar lah. Kau semua nak ada kelas petang ni? Ada kelas ke yang lain petang ni pukul 5?
Tak ada.
Kalau tak ada okay. Yang tak ada ni nak stay ke nak end up kelas? Saya tak kisah nak habiskan kelas ni. Kelakar lah korang ni. Macam ni, korang dengan saya kan tak perlu malu. Kalau korang kata korang nak berhenti, cakap je. I'm open to this. Sebab saya akan buat sedaya upaya saya. Jadi kalau awak tak stop, saya akan ikut cara saya, kan? R3 plus R6 keep in R7. Good. How kupon. Anis, dapat tengok tu? Alah, kesian. Tak apalah kalau macam tu. Okay, it's okay. Up the class. Let's see. You guys have question. Please write it on a piece of paper and let me know next week. Is it okay?
Okay, sir.
Okay, sir.
Okay. That's it. Have a nice day. Bye.
Thank you, sir.
Welcome.
Thank you, sir.
Assalamualaikum, sir.
Waalaikumsalam.
Cina Muslim.
Thank you, sir.
Welcome. Thank you.
Selamat.